Welcome to the GOB laboratory at Mercy University. In this experiment, we're going to separate a mixture of food dyes using a technique called chromatography. In part B of this experiment, we're going to make use of a chromatography column to separate a mixture of grape Kool-Aid into its red and blue components. Here are some materials that we're going to make use of in part B of the experiment. Step 1 is to take your syringe and fill it with 70% isopropyl alcohol. We're going to use the isopropyl alcohol to clean our column prior to use. Firmly secure the SEPAC cartridge to the front of your syringe, making sure that the long side of the cartridge is pointed toward the syringe. Now slowly push the 70% IPA through the SEPAC column, dropwise. Go slowly and avoid applying too much pressure so that you don't damage the column. Now remove the SEPAC cartridge and refill your syringe with 10 milliliters of distilled water. We're going to use the water to condition our column since our Kool-Aid mixture is also dissolved in water. Now reattach the SEPAC column to the syringe and slowly flush the syringe with the water drop by drop. Again, remember to go slowly so that you don't damage the column. Now that you've conditioned your column, remove the SEPAC cartridge and refill your syringe with 10 milliliters of your grape Kool-Aid solution. After filling your syringe, reattach the SEPAC cartridge. Next, we're going to slowly push our grape Kool-Aid solution through our SEPAC cartridge in order to load the column. This puts our Kool-Aid mixture on the column so that we can extract the individual colors using different concentrations of isopropyl alcohol in the next step. The liquid should come through clear. All of the grape coloring should be left behind on the column. Once you're done loading the column with the Kool-Aid mixture, remove the SEPAC cartridge. A successfully loaded SEPAC column will look something like this. In the next step, we're going to fill our syringe with 20 milliliters of 5% isopropyl alcohol. We're going to use the isopropyl alcohol in order to remove the red 40 color from the chromatography column. After you've drawn up the 5% IPA solution, reattach the SEPAC column, again making sure the long end with the purple coloring is facing toward the syringe. Now position the syringe above your first test tube and begin to push through the 5% IPA solution. You should see that the 5% IPA solution begins to remove the red color from the chromatography column while leaving the blue color behind. Continue to collect the elutant until you've fully removed the red dye from the column. A successful separation will leave only blue dye remaining on the column. Now remove the SEPAC cartridge from your syringe and refill your syringe using 10 milliliters of 25% isopropyl alcohol solution. After filling your syringe, reattach the SEPAC cartridge, making sure that the long end is facing toward the syringe. Slowly push the 25% IPA solution through the column in order to remove the blue dye. Continue collecting the elutant until you fully remove the blue dye from the column. Again, proceed slowly as you push liquid through the column, being careful not to apply too much pressure or to damage the column. As you complete the separation, the last few drops should be clear. After you've completed the separation, remove the SEPAC cartridge from your syringe and refill your syringe with 10 milliliters of 70% isopropyl alcohol. This solution will be used for cleaning our column before storage. Now reattach the SEPAC column to your syringe and push the 70% IPA through into waste or into another test tube. If you've successfully removed both dyes from the column, the solution should come through clear. Now remove the SEPAC cartridge from your syringe and place all of your solutions into the provided waste container. A successful column chromatography experiment should yield two distinct colors. To identify the dyes present, compare to your food dyes chart and compare to the ingredients list on the back of the Kool-Aid packet.